Hello, and thank you for joining me as we discuss this last little section of Unit 4. So we're going to kind of start putting everything together for the unit. But this lesson is going to be on balancing chemical equations. And this is something that's very important we do all the time. So at the end of this lesson, you will explain why we have to balance chemical equations. You'll be able to distinguish between what are called coefficients and subscripts in a chemical formula, and you will be able to balance skeletal chemical equations. So I'm going to give you the equation, you just have to balance it. So here we go. A chemical equation represents all the chemicals in a reaction, represents chemical reactions. So you have reactants on the left, you have an arrow, and you have products on the right. We have what is known as a skeletal equation, which doesn't include amounts of reactants and products. For example, I have iron plus oxygen produces Fe2O3. You should be able to name this. So we are going to uncross our subscripts, and we're going to get this as iron 3 oxide here. So that is iron plus oxygen is iron 3 oxide. So now we're going to look at balancing. But the question is, why do we need to balance? So there's this concept in science known as the law of conservation of mass, which states that mass or matter cannot be created or destroyed. And so we need to have the same number of atoms or same amounts of matter at the beginning of a reaction as we do at the end of the reaction. Essentially, we need the same number of atoms of each element on the left as we have on the right. So same number of atoms on the left as we do the right side of the arrow, or the equal sign, essentially. So in order to do this, some steps to follow. First, write the number of each atom below the chemical equation. And I'll give you a practice example. When you do this, you can keep polyatomic ions together if they're the same on both sides of the reaction. To make things the easiest, I would start with the most complicated compound, so the one that looks the scariest. For example, your polyatomic ions is a good place to start. And then if you can do so, save hydrogen and oxygen for last. It tends to make it easier in the end. You don't have to, but that's how I would suggest you do it. For example, we have, again, this is iron plus oxygen produces iron 3 oxide. Some terms you need. One, we're going to balance this. And so I'm going to write down Fe and O. These are my two elements. On the left side, I have, right now, I don't have any subscripts, no numbers, so I have 1 iron and I have 2 oxygens. On this side, I have 2 irons and I have 3 oxygens. So in this case, you can balance either of them first, not a big deal, but you're going to notice that your oxygens, I have a 2 here and I have a 3 here. The least common multiple between 2 and 3, if you multiply them together, is 6. So I'm going to double this one and get this to 6, and I'm going to get this one to 6 as well. So I'm going to take 3 times 2, and I'm going to take 2 times 3. So what I've done is I've placed coefficients. These are whole numbers placed in front of the formula, which indicate the number of molecules in a reaction. So my subscript, this 2 and this 3, tell me how many atoms are in a molecule. So 1 molecule of iron 3 oxide has 2 irons and 3 oxygens. When this reaction takes place, my coefficient is going to tell me how many molecules I get. So for now, I have 2 times 3 is going to be 6, and 2 times 2 is going to be 4. On this side, I have 3 times 2 is also 6. I need 4 irons, so I'm going to put a 4 here. So subscripts tell me the number of atoms in a molecule. My coefficients, this tells me I have 4 iron atoms, 3 oxygen molecules produce 2 iron 3 oxide molecules. That's what my coefficients tell me. We can change these in a reaction. You cannot change your subscripts. That's very important to remember. Okay, let's try this one. A little bit different. I have carbon, I have hydrogen, and I have oxygen. On the left side, I have 2 carbons, I have 6 hydrogens, and I have 2 oxygens. On the right side, I have 1 carbon. Undo that. I have, just to keep everything the same, I have 2 hydrogens, and this time I have 2 oxygens and I have 1 oxygen, which makes 3 oxygens here. So first, balance the one that is the most complex looking, or keep polyatomic ions together. We don't have any. So second, balance the most complex looking. None of these look super hard. So the last suggestion was to keep oxygen and hydrogen for last. So that means let's balance carbon first. So if I put a 2 here, because I have 2 carbons on this side, this is going to give me 2 carbons, and it's going to give me 4 plus 1 is going to be 5. My hydrogens, I have 2 on this side and I have 6 on this side. So to get from 2 to 6, I need to put a 3 here. 2 times 3 is 6. 3 times 1 is 3 plus my 2 times 2, 4 over here. So 4 plus 3 is 7. So everything is balanced now except for oxygen, and because oxygen's by itself, that works out really well. So what I'm going to tell you to do is I only need to change this number. I have to go from 2 to 7. Well, I can't do that normally, but if I take 2 times 3.5, I can put 3.5 here, and that's going to give me 7. I'm going to double check, make sure everything balances, which in this case it does. Now, to get rid of this, we can double everything. So I'm going to take this first number times 2. 1 times 2 is 2. I'm going to take this number times 2, and I'm going to get 7. I'm going to take my 2 here times 2 is going to be 4, and my 3 times 2 is going to be 6. And now if I go back through and count, I have 2 times 2 is 4 carbons, 2 times 6 is 12 hydrogens, and 7 times 2 is 14 oxygens. 4 times 1 is 4 carbons. 4 times 2 is 8. 6 times 1 is 6, and 8 plus 6 is 6 times 1 is 6. 8 plus 6 is 14. Why did that not work? Oh, I'm doing hydrogen. That's why. My apologies. I was jumping the gun. We're doing hydrogen. 6 times 2 is also 12. There we go. And now I have 7 times 2 is 14. 4 times 2 is 8. 6 plus times 1 is 6. 8 plus 6 is 14. So this is balanced. That is how we're going to balance chemical equations. Here are some for you to practice. Try all of these. Pause the video. I have the answers on the next slide. So pause this quick, work through these, and then check your answers here. Okay, there's your answers. See if you match what I had. Notice this one here, they're all balanced. Trick question. But that's possible. So make sure you're careful. If you have questions on this, we will do more practice. I can help you kind of look through it. You just have to take it one step at a time as we go. Your last couple questions. 1, why do we balance chemical equations? 2, what do coefficients tell us about a chemical equation? 3, what do subscripts tell us about a chemical equation? And 4, which one can we change in order to balance the reaction? So subscripts or coefficients, which one do we change? All right, answer those questions. If you have questions or have some confusion, come see me. I'm more than happy to help you out with this, and we will continue on and move forward. This is something we're going to use for the rest of the year, so it's really important that we can do this. Let me know what you have for questions and concerns. I look forward to seeing you again next time. Thank you and enjoy the rest of your day.